a spell is cast. Polyglot, it's built to last. Limitless, we're unsurpassed. Kubernetes, edging more, running smooth from shore to shore. Every app we're keeping score. With wasmCloud, we'll always soar. Kubernetes, edging more, running smooth from shore to shore. Every app we're keeping score. With wasmCloud, we'll always soar. Spotlight, spotlight on wasmCloud. Rising high, we're feeling proud. Stack and scale, show the crowd. You're the star, we'll shout out loud. Build and manage with no fear. In the hybrid future's near. Every option now is clear. wasmCloud, you're our sphere. From the edge to the cloud top, this momentum never stop. Innovation we won't drop. wasmCloud, we're over the top. Spotlight, spotlight on wasmCloud. Rising high, we're feeling proud. Stack and scale, show the crowd. You're the star, we'll shout out loud. Spotlight, spotlight on wasmCloud. Rising high, we're feeling proud. Stack and scale, show the.
Hey everyone, and welcome to the Cloud Native Project Spotlight series. We're back, and today I'm excited to have Brooks Townsend with us exploring wasmCloud. Brooks, thanks for joining us finally. Could you give yourself a brief introduction and kind of share what drew you to the Cloud Native space?
Hey Steve, yeah. First of all, thanks so much for having, I guess, myself and wasmCloud on here. It's super exciting to kind of spread the good word of Wasm and have a fun live session to do it on. So yeah, intro. My name is Brooks Townsend. I've been working on wasmCloud and WebAssembly in the backend by extension since late 2019, so for about 5 years now. I started my career in cloud native backend engineering. So I was deploying Kubernetes clusters at a top 10 US bank. That was such a great time. And I was deploying, I was writing services in Rust. That's when I stumbled on this little project. It was called something different at the time, but that evolved into wasmCloud. So I first really got into the cloud native ecosystem because of the open source of it all. It was so cool to be looking at an ecosystem of these incredibly mature and sophisticated projects that were all open source. There's this whole ecosystem of people being friendly to each other and wanting people to contribute to their project. And that was something that when I took a look at open source at first, like when I was in college, was really daunting. It was really hard to try and figure out if you find some open source project like, Red Hat, Linux or something, how you could even contribute. But then the CNCF, the Cloud Native ecosystem, has this whole wealth of people who are willing to help. So I just want to really call attention to that, because contributing to open source at first can be a little intimidating, but now I think 100% of the code that I've written in the past year has gone into open source, and it's such an awesome ecosystem to be a part of.
That's awesome. That's quite the pivot, right? To go from being like on the inside and actually leveraging the project to like committing completely to all of the open source tooling and the kind of the whole ecosystem behind it, which is great. Like that's really cool. Um,
Yeah.
yeah. So for those who might be new to WASM and wasmCloud in general, do you want to give a brief introduction to it and kind of explain what it's all about?
Yeah, I'd love to. So wasmCloud is a WASM native orchestration platform for distributing applications to any cloud, Kubernetes, or edge. So just like running in the current cloud native ecosystem, applications in containers, containers really need this robust distribution and scheduling platform like Kubernetes or Nomad to truly shine. And we see the same potential and need in the WebAssembly ecosystem. So wasmCloud is really built for people who want to build applications with WebAssembly. And I've got kind of a whole spiel on what is best made for that, what's great for writing applications in WebAssembly. But I'll pause there because I think that's the best way to look at it from the start.
Okay, so interesting question from me is like you've mentioned the word wasm a couple of times. So like how would you explain wasm as if I was an Uber driver and didn't really have a clue what those four letters meant?
Okay. Yeah, so I think that the single most impressive piece of WebAssembly right now, so I'm getting into your Uber driver and telling you what I'm doing, or into the Uber. The single most important piece of WebAssembly right now is the component model, and that is this set of standard interfaces that really dictate you being able to work with something that you understand how it works, you understand what it needs to plug into. And if you think about yourself as an Uber driver, Steve, when you get into your car, you probably, well, I don't know how much you know about cars. You may not know all of the complex inner workings of a car. You may have just driven a Toyota and now you've just gotten into a Honda, but you understand the standard capabilities that make a car work. Like you have the gas pedal, which, makes the car goes forward. You have the brake pedal, which makes it stop. You have the steering wheel. And those standard common capabilities, or you really can think of them as a human interface to the car, work the exact same no matter what car you're in. Now, there's of course innovation and different implementations. Tesla has a go pedal instead of a gas pedal, but even though there's innovation there and things change, it's the same interface. And that's what working with WebAssembly is like. You understand a common language, and no matter where you go, you have the same common language that you can use to communicate and drive your car as an Uber driver. Does that kind of help, Steve? Does that help like the,
Yeah,
you know,
that resonates. Like
motivation?
I was unfortunately trying to like see myself as an Uber driver, uh, which was an interesting thought that I exercised that I just went on for the last couple of minutes. But yeah, it does make a ton of sense, right? That component model and how you're essentially building out interfaces to do the generic type of work, but it doesn't really matter what specific implementation that you're going with. It still kind of functions the same way, which is great. And then kind of moving on from WASM into wasmCloud, right? So wasmCloud kind of it has a an interesting and innovative approach to how application development is done using WebAssembly. So can you just highlight some of the core features that folks may not be aware of?
Yeah, so the core features, I spoke kind of just as an Uber driver, as the Uber driver metaphor about the component model, these standard sets of interfaces which make up the building blocks of applications. What wasmCloud allows you to do is extend those interfaces at runtime, provide different implementations for different clouds, different Kubernetes implementations, different edge or even local implementations for capabilities. Capabilities, more concretely, being things like accessing a key value store, accessing HTTP, accessing a message bus, or doing distributed logging. Those key building blocks that form applications today. wasmCloud provides those implementations, allows you to extend the platform with your own interfaces that don't neatly fit into that like pre-configured capability box. And what we really do well is the distributed orchestration of WebAssembly components. So what's really important for us, we follow this application mantra of distributed first, where when you're writing your applications and deploying the different microservices that may communicate with each other, they work the exact same locally as they do distributed across multi-cloud, in a Kubernetes cluster, outside of a Kubernetes cluster, on the edge. That's all facilitated by our Lattice network, which is powered by the CNCF project NATS, which you may or may not have here on a project club spotlight here pretty soon. So I don't know if they're on the schedule. Just, they'll be somewhere.
Work in progress.
Yeah. So the key piece that wasmCloud brings here is the same level of orchestration that Kubernetes does for containers for WebAssembly. So what we really want is to bring that declarative deployment model that people love from the, here's a manifest with all the things that my application needs. Please go make it happen. That user journey is very key to us. The ability to scale these WebAssembly components on many different machines and have them communicate with each other without you needing to tweak your application code to do that. And then the abstraction into capabilities really gives you this ability to write just business logic, compile it to a WebAssembly component, and then that single binary can be the same thing that you run locally to test, promote to QA for further testing with production grade capabilities, and then finally deploy to production. So there's a whole lot there, and WebAssembly and the CNCF ecosystem are huge towards our mission as an application platform.
So finally, we're going to get the "it works on my machine and it will work in production." Like, we're going to finally solve it once and for all. I swear it's been like 20 years since everyone's been batting that drum saying we finally fixed it. So I'm I'm looking forward to that. So what are the kind of challenges that you guys focus on for, like, what I would call like an enterprise engineer, right? That's familiar with, I've bundled my application in a Docker container and I've shipped it to Kubernetes. Like, what things are you kind of really tackling and diving deep on?
Yeah, this is something I feel very passionate about because I was this developer. So you're an application developer at a large enterprise. You have this idea to improve your business. And, when you think of it in your head, you essentially, you may be out at a happy hour with some of your coworkers. You start sketching this idea of an application on the back of a napkin, right? Like you say, oh, it needs to take in requests over HTTP, and then we'll process that, and then we'll store something in some database. And then, that's how we're going to, I worked at a bank. So, you could think of something like that's how we're going to verify that this transaction was spent at a particular merchant. And that's how we're going to give people the certain amount of cash back, little business logic that's always particular to a domain. And when you think of it in your idea, or when you're in your head, the idea is great. You come up with the application, you know what needs to go into it and to make it work, and you know what you're going to write versus you're going to bring in some open source library or use your enterprise database solution for. But then when you actually get down to writing that application, you start bringing in all these open source libraries, you start writing a bunch of boilerplate code to connect to your, to serve an HTTP server, that Go code that all of us have written 1,000 times. You start writing some code to bring in your corporation's library to connect to the central database and the logging mechanism. And then let's say you get all of that done, you're finally ready to build, you test locally, works great. Then you need to think about delivery. You can only deploy on Kubernetes. So you have to pick your application's base container. Which base container should I use? Can I just use this one that has all the language tools? No, that's really huge. I need to use this minified container. You can kind of see where I'm going with this. There's a whole lot on top of just the original idea. And then comes security, and then comes the maintenance of all these libraries that you brought in over the development. And all of this really, at some point in this journey that I've described, an average developer is likely to just throw up their hands and say, whatever, I don't really feel like finishing this. Even if you get it deployed, now you have to maintain it, which takes up a whole lot of your time. And what we really want to do is make that not what application developers need to deal with. So the whole goal with using WebAssembly components as the unit of compute is you get to write code in a language that you choose, that you understand. So if you're a Rust developer or a Go developer, you just write the code in a language of your choice and compile it to a WebAssembly component. And then the capability abstraction model is something so that you can describe the non-functional requirements like HTTP logging, accessing your company's database. You can describe that at your application level in terms of an interface. And then you can plug in those libraries at runtime so that now when you deploy to production, you're deploying this one architecture and OS agnostic binary. You have declared capabilities that you can swap out at runtime. So instead of you replacing your entire application because your distributed logger had a vulnerability, that's something that the platform team does and really just vastly reduces this friction that we see. That's the number one user journey that we see at these big enterprises, is that all of these different application teams essentially need to go through the same steps of maintaining their application because all of them use the same shared libraries in order to get their application to work. So even when there's a vulnerability in not their code, you are still responsible for maintaining it, and that's a big drain on productivity and motivation on the
Yeah, for
developer
sure,
side.
right? I'm sure application developers that are watching this are going to be like gloriously satisfied with you saying, "Oh, I don't need to worry about upgrading and changing all the logging because of there's a vulnerability in one of the logging frameworks." I think that's, that alone is going to save a bunch of time, and that's probably relatively easy case. And there's much more complicated cases that I'm sure this is going to help with as well, which is great. So I want to kind of put the stage over to you and give you the time to shine. So I understand you got a little demo for us. Do you want to give us a little brief overview of what you're going to be showing?
Yeah, absolutely. Steve, I actually have a couple of slides that I could run through to
Okay,
just like talk a little bit more
sure.
about wasmCloud to kind of give a visual to this, and then I do have the demo kind of in the middle of this, so I think this will work great. So, as mentioned, wasmCloud is a WASM native orchestrator for distributing and deploying applications declaratively across any cloud, Kubernetes, or edge. And when talking about the core features, I spoke a lot during the kind of intro as Steve and I were talking around what wasmCloud does well as an application platform. The key piece, speaking here around the common interfaces, is building applications with wasmCloud is simpler because of this abstraction of business logic and these common capabilities that make up all cloud native applications, whether it's telemetry or observability or logging or accessing HTTP. All of these things are essentially like Lego blocks that you can plug in at the platform layer, and get those as a part of your application is something that you can use at runtime, but is not something that you have to maintain on your own. wasmCloud is built really well built specifically to work within the cloud native ecosystem. So these integrations are all standards based, whether it's on the WebAssembly side or on our side for being OTel observable or being deployable on Kubernetes, etc. So these applications, what this really allows you to do, in addition to having a more portable unit of compute, you can use these common interfaces to get implementations for your specific cloud. You can develop not just without lock-in on an individual like cloud basis. You're also not locked into an individual version or implementation. So you're freely able to swap these implementations at runtime, which really makes the maintenance and the composition of these applications easier and something that really feels more joyful to make with just your business logic and then composing it at runtime. Now, I spoke a little about the orchestration piece on different devices, different servers, and the key pieces that wasmCloud brings to this is the deployment. So our application deployment manager, which is just essentially a reconciliation loop, but for declarative applications, putting this across different infrastructure, and then having a seamless flattened topology network underneath it with NATs to serve our applications. means that you can run WebAssembly components on a single machine. We deal with the scaling on the wasmCloud level. It's not something that you program into your individual application. We auto scale up to the load that you're currently receiving on the application side. And since it's WebAssembly, it starts up in less than a millisecond, which is pretty wonderful. And it doesn't use any resources passively, which is pretty great. We also handle the distributed clustering of these wasmCloud hosts, which can dynamically join and leave a cluster at any time. And with that also comes the resiliency, the automatic failover, and the reliability or the availability of being able to spread these wasmCloud applications across many different pieces of infrastructure. And I spoke a little bit about this when talking about the responsibility of a developer today in the container era is still not an ideal abstraction for application developers. You still are tightly tied to a specific underlying infrastructure. Docker and containers have done a really, really great job of getting you to care less about the underlying infrastructure as long as it's Linux. You still do care about the operating system that you're bringing into your container, and you are still building containers for a specific platform. This is something that this is something that WebAssembly does not do. It is not tied to a particular architecture or operating system, which is great. And the wasmCloud motto here is to take these WebAssembly components and abstract these common libraries that we use to build applications away from the developer. So again, all of this becomes a part of the platform that you can ship, or if you're doing internal developer platforms or your organization, the platform engineering team is the one who gets to decide how these capabilities are given to developers. And then applications are just business logic in that one really nice portable application component. Now we have I won't go down like the whole list here, but just to give you something concrete, if you look at the idea of a key value interface, we have implementations for Redis, or I guess Valkey, NATS, and HashiCorp Vault. All of these interfaces that you can see that we support on this page are actually part of either the WASI, which is the WebAssembly, thanks Apple, the WebAssembly systems interface proposals, or they are something that is actively going through the proposal process. So we support these abstractions as standard interfaces. We also add on a couple of our own, including secrets. We added these next two are technically custom interfaces, but we wanted to test our custom interface support by adding native interfaces for Postgres and Couchbase. Both of those, which we've designed with the WebAssembly interface types IDL. So we wrote out these interfaces and then implemented them at runtime with the capability. And we also have support for key value in NATS KV. So this is something that's constantly growing all the time. And we have SDKs in Go and in Rust for writing custom capabilities. So if you need something outside of kind of the standard scope of applications, then this is how you can do it. Now, last thing before I can move on to the demo, because I think that I think it's going to be exciting just to kind of take a look at it in the first place, is to talk a little more about our application deployment manager. Now, this is based on the open application model specification. We wanted to make sure that we were using, again, as many common standards as possible. And this came up as a really nice abstraction for an application. This looks exactly like what developers and platform engineers are used to working with today, which is a declarative manifest where you lay out all of your application components, the links to different services, the links to different components at runtime to allow them to communicate over that distributed network. And then the configuration here is all kind of shipped as this one individual application. So I'm using this in order to deploy locally, but this is really all that you need to know here. WADM is another project under the wasmCloud umbrella that runs a reconciliation loop, kind of like Kubernetes, to make sure that your application deployments, your application components are deployed. Okay, enough slideware for now. We've got some more exciting stuff that I'll show you a little bit later. But for now, why don't we go ahead and move on to a little bit of a demo. So this demo we call wasmCloud.space, and I think you'll see why in just a second. So here, let me move out of here. We'll come over here. I'm keeping it all light mode because it was already light mode, but dark mode does look pretty cool here on the space thing too. You know what? We're going to stay here. So what I have here, and we'll start with the application and we'll talk about how it's actually organized, is an image, a machine learning image classification application that's built using multiple different wasmCloud components and common capabilities. So the point of this application, we've got this nice little globe visualization here. The use case, what we wanted to build was an ML, a model that is built for classifying whether or not an image contains a boat. So this is something that could be distributed on a far edge. You can be distributing these different components that make up this demo, partially on in a central server, partially on the edge, partially potentially even in a satellite that is actually taking the images themselves. But why don't I just go ahead and show you how it works first. So let's see, we've got a boat, a real boat here. Let's go ahead and upload that image. We upload the image, we resize it down to a smaller, an actual smaller size so that we can send that over the wire with less of a latency and a transfer penalty. You know, we're essentially minimizing the ingress and egress cost here. We can see that, yes, this is in fact a boat. Great. So why don't we go ahead and open up another one? We can pick up something that is definitely not a boat, like a butterfly. We can send that off for classification. We can see that, in fact, no, this butterfly is not a boat. I'll do one more just because it's fun. We do a wasmCloud logo. We'll do a dog. We'll do Oscar, one of my teammates' dogs. We'll see if this dog is a boat, which of course, this dog is not a boat. So you're seeing this in action. This is an application that you could completely build using containers today. And really a massive part of this application is the underlying image classification, which we're using Ollama for. So why is it so special? So why don't we go ahead and move back to the slides real quick. Sorry, warning for dark mode. And let's take a look at the architecture of this application. And then I can dive a little bit more into the code or into individual pieces of this application as well, depending on if folks have questions. So the actual flow of this application is we have a UI, you know, we are navigating to hit this endpoint where the application is running. And we have a custom capability, which is implementing the standard HTTP interface, which is basically like a router. Now, this router is linked to a couple of different components. One is specifically built to serve UI assets. So we can serve this component at many different edge locations, so, you know, kind of like a CDN to make sure that fetching those assets is cheap and can pull up as quickly as possible. We have an image handler, which is used for uploading images. And what we actually do will we'll receive that image. The handler will resize that image and kind of bin pack it to make it as small as possible, and then store it using the standard blob store capability for later processing. Now, when we do that, we'll also register a job, which we store in Postgres. And there's another component which is responsible for taking that job, the image processing handler, which is responsible for taking that job and then actually processing it. That component then uses the image analyzer, which is really doing the important piece here. We will send a request out to Ollama over HTTP. So this is something that actually this component actually needs to run right next to the machine learning model. So it needs to be on a heavier weight machine, needs to be somewhere with a GPU, ideally not required. You can do it with a CPU too, but GPU is better. And then finally, at the end of all of this, once we've figured out if this image is a boat or not, we will update the job in Postgres, send the response back to the original image handler, and then you'll get your response back, whether or not this was a boat or not. So as I kind of talked through the deployment architecture of this, right? This is a little bit more of an application level architecture diagram. This is your napkin sketch where you come up with the way that you want your application to be organized in terms of code. This is the part that as a developer you actually need to be concerned with and write. You write the code for the image handler or the image analyzer. You make sure that your UI assets are bundled up correctly, and that you're interfacing with Postgres, with the Postgres interface. What isn't captured here is everything that I kind of talked about as we talked about like actually deploying this, the requirements at runtime. And the great part is that that's kind of handled when you write up your manifest, when you actually go to deploy onto the wasmCloud platform. So you get to write these, it's similar to like a taints and tolerations mechanism, where you can make sure that your HTTP router and your UI assets and your image handler components are all running as close to the user edge as possible so they can serve your HTTP requests as quickly as they can. Now, the image analyzer is really important to run on a machine where there is a GPU. So you can use the deployment manager for wasmCloud to make sure that that component is running on a machine where there is a GPU, so that when you interface with the Ollama, the Ollama large model, that's running right next to it. So you essentially get to optimize this application and scale it across different machines without specifically engineering it to make sure that these individual components know which components are communicating or where they're actually running. From the application level, you don't care where they're actually running. It really comes down to your production platform requirements. So a common way, oh, did I take that out? I think I did. So this is essentially the architecture of the wasmCloud space application. Now, one thing I think it would be useful if I come out of full screen here to show is the actual manifest that powers this application. So this is something where you can really kind of see the organization of this app into different individual components. So this should be large enough, but Steve, let me know if it's too small. This is the declarative application manifest for the wasmCloud Space app. So we have our image analyzer component. Here, we're just loading it from the local WebAssembly component that we've built. But you'll see we also have a copy of this that loads from remote OCI registries. So the way that we distribute these WebAssembly components and the capabilities themselves is actually completely over or using OCI. The CNCF actually has a WASM working group, which published recommendations for publishing WebAssembly components as OCI artifacts. So that is what we use. We've got our configuration for the image analyzer component, making sure that this is where it's reaching out to access Ollama. Here's the model to use, and then you can engineer the prompt here as well. So pretty classic like deployment of a little microservice that uses a large language model. Now we also have a link, have two links actually, but the links at runtime dictate what components are allowed to talk to each other. So you can see that the image analyzer is going to use this HTTP capability. And at runtime, that's going to get filled in by this capability, which is, again, another OCI artifact, not running as a container, just a different component. And we're going to make sure that this HTTP client is deployed as well. So this is how the component's actually making the HTTP request. We have other capabilities down here for Postgres and the blob store. Since I'm deploying this locally, this is actually running with the file system. But you can see when we run in the remote or the production deployment mechanism, we have links to the blob store using the same interface. But down here at the bottom, we can scale to it. We are actually running this blob store, which is the implementation for running in Azure. And then same thing for Postgres, we're using one with TLS enabled, and the HTTP router is being scaled across different workloads. So we have a little bit of a comparison here between the local deployment manifest and then the remote deployment manifest. The important thing is that these components are using all the same standard capabilities in order to interface with that. I'm happy to kind of walk through the code a little bit, but I think what would be most interesting in the short term is if we take a look at one of these components, the WebAssembly interface types that are declared there. So this is something that's very different from the existing ecosystem in terms of what you can see when you inspect a deployment artifact. So this is the WebAssembly component. If we take a look at the code here, we can see how the actual task manager is implemented. But this individual component, we can see this organized into a package. This is a set of imports and exports, and these are just functions that the component is going to call at runtime. We can see at runtime, it's going to log, it's going to use Postgres types and the query ability in Postgres. We are going to use some of the standard interfaces for like outputting to standard error and for using streams. And then we're going to export a custom interface called wasmCloud Task Manager Tracker that you can use to call this function and see, the current status of a task. Now, this is a very important part of the WebAssembly component ecosystem because when you distribute a container, most of the time you need to crack that container open in order to actually understand what it needs to do at runtime. And often when it comes to security, there's just different layers of security that prevent a container from doing things. The component ecosystem is very deny by default security, and deny by default capability is even a better way to put it, where everything you see here is everything this component will try to do at runtime. The capabilities that it needs, the capabilities that it's going to expose to other application components in the system is all captured right here. We know for a fact that this component is not able to access HTTP. It's not actually able to send messages on a message bus. And that is all thanks to the sandboxing of the WebAssembly runtime. We use wasmTime under the hood. I understand that there's a lot of different pieces of the ecosystem. So what's really important is that when wasmCloud loads this WebAssembly component, it knows exactly what it's going to be able to do at runtime, and any other function that gets called or any other access that it attempts to do of the outside environment is denied before you can even start executing the component. So it's really cool to look at it from this perspective. And as an application developer, what I really care about here is I can express the non-functional requirements that my application needs, like file system and logging and Postgres. And the code that I actually write just needs to be the actual business logic. If I take a look at the task manager, see, I didn't even know this. I didn't know that the task manager was written in Go, but you don't even need to know when you're building this application or when you're working with the component, whether it's written in Rust or Go or TypeScript or Python. You can see that the only dependency that we have in this component is actually the generated code from the interface and the format package. So in order to work with Postgres, in order to work with logging, all of that is driven by this WIT interface, which we've declared a dependency on these standard interfaces. So there's a whole lot here when it comes to developing the application. There's a whole lot when it comes to or in terms of innovation when it comes to this ecosystem. I think the really important thing is that this application slots right into the existing cloud native ecosystem with wasmCloud. It results in something where you can write code in a language of your choice, and you get this really nice, small, I don't think I touched on it yet, but this actual component that's handling the task manager is 250 kilobytes, really tiny, platform agnostic binary. And this really allows you to focus on the business logic of your application while writing code in a language of your choice. And then at the same time, leaving the pieces of the platform, which should be part of the platform, to the platform, like the management of the Postgres library and the distributed logging capability. So I want to pause there just to make sure that I address any questions maybe from Steve or any from the live stream before we maybe talk a little bit more about the production use cases that wasmCloud has seen additionally right now in the ecosystem.
Yeah, I've got a ton of questions. Like my my main one, right, is I come from a background of platform engineering. So how does WebAssembly improve my life as a platform engineer and also application developers' lives? Right, where do you see the kind of biggest wins for someone kind of questioning whether they should go down the WASM route or not?
Yeah. I think that, before we got to the current day where in the cloud native world, I think there's this whole advent of platform engineering and DevOps and GitOps and MLOps, all these ops roles where previously, developers would kind of take this application and then throw it over the fence to the platform team to deploy. And like we all kind of decided that that was a bad thing to happen. When we're working with components, we're getting a little closer to that, going back in that direction. Now, hold on, I have a point. It's good, I promise. When you look at the application component, like I showed during the demo, you can see everything that that application is trying to do. So when it comes to platform engineers, if you're doing something like writing an internal developer platform for your engineers, you can distribute common interfaces for them to use in order to work with your internal requirements. One of the big ones that we saw when we're working at a bank is we would have like an internal secrets management solution. And we had an interface for working with that in every single language that we supported for microservices. So we had a team that would maintain this one capability for Java Spring Boot, another team for Go, another team for Python, another team for Node.js. All of them are maintaining this common capability in their respective languages. And that leads to functionality being included in one SDK and not being included in another. And even though you have the super custom capability and library, all the application developers need to import that library. And then if there's an update, all of them need to go and update that library to the newest version, rebuild the container, redeploy to whatever internal distribution or public cloud that they have. So I truly believe that this component model for WebAssembly, the observability that you get into like an individual application component really results in a nicer experience for the developer and for the platform. And then once you get to running in production, we can step through the code if you want, but there's nothing in there that dictates, how I'm getting my HTTP requests. There's nothing in there that dictates, what scale I need to run this component at, and then how do I manage failover, and then running in multiple regions. That's often something from both the app developer and the platform side that you have to engineer explicitly. And now that's something with the distributed network of wasmCloud that just kind of comes for free with your application. So the scaling, the connectivity, that is a big piece of our kind of application topology. So I think that was a pretty long-winded answer. But all I mean to say is I think that the WebAssembly unit of compute is a much nicer abstraction for applications. And then wasmCloud gives you a lot of power at the platform level to run that across many different things based on your current requirements, which is often pretty hard to meet.
Definitely, yeah. And what exciting kind of developments and plans are in the pipeline for wasmCloud? Is there any kind of spoilers that you can give everyone?
Yeah, we actually demoed something at our last wasmCloud community meeting, which is going to land here very soon. But often when you work with WebAssembly components today, it works very, very well for applications that you decide to write in WebAssembly. So you go out in a language that you know supports WebAssembly, and then get to write that in terms of the interfaces, and then you can compile the component and you go from there. What we're seeing now that the component model has been a standard for for, I guess, a little over half a year now is integration into native language libraries. So if you look at innovations in Go and in Rust, in C, and there's a whole wide variety of languages that are adopting this natively. The ability to take an existing application and have it look and feel and is idiomatic code for that language and compile it to WebAssembly. Those innovations are really happening now that there's a standard uh, API to get behind and use for communication. So you should, if you take a look at how everything looks now, you'll see from the wasmCloud side, we have like specific SDKs that will compile down to the standard interfaces, which works really well. And coming down the pipe, through the end of the year, you'll see things like taking an existing Go application and just compiling it straight to WebAssembly, and then it works with the standard interfaces
Now I'm
when it would
interested.
not work with syscalls. Yeah.
Yeah, that's going to be huge, right? The ability to be able to take something that you've got running previously and kind of convert it to WASM in a couple of clicks and a couple of commands. Hopefully, that's game changing, right? So obviously
Yep.
you're aware, right? The cloud native club, the kind of mantra is to inspire the next generation of cloud native engineers. So like as someone that's kind of done that transition from leveraging cloud native open source tooling to actually building and contributing to it, like what's one piece of advice that you'd give someone who's looking to contribute to projects like wasmCloud or others?
Yeah. I think that if I had to talk to someone who hasn't contributed to open source before or is kind of getting into cloud native for the first time, what I would really try to instill in them, being on both sides of the fence, is that people who are running successful and good open source projects are more excited for you to contribute to them than you are to contribute to them. We get so pumped up to see people come into the wasmCloud community and take an issue or take interest in something that we're working on. And I think if you're interested in taking an issue, of course, with wasmCloud, we'd love to have you. If you're interested in taking an issue, make sure to take good use of the GitHub feature where you can take any repository and add /contribute to the end of the URL. That'll actually pull up all the good first issues that people have marked. That's like a standard label in GitHub in the repository. And this is something I will be honest, maybe not everybody would love this, but what I love encouraging people to do is if you're interested in taking an issue, one of the best ways to show interest in that is to kind of sketch out an idea and start on it, and then open a draft PR in the repository. And like maybe 1 out of 100 times you'll get told like, hey, I would prefer if you commented on the issue before opening a PR. But I love draft PRs as a point of collaboration to show, especially in our increasingly distributed world where we're not all working in the same office, someone can put up a PR and show that they were interested in taking an issue and what their thought process was. And then, the maintainers, the experts can point you in the right direction or give suggestions. And you'll be surprised at how receptive people are to that.
Yeah, definitely. I can echo that. Right, I'm a maintainer of the Flux project, and that's kind of how I got started. Right, I started by making some minute, tiny changes to like the GitHub actions because that's where I felt comfortable, and then kind of went from there. And now,
Cool.
yeah, lucky enough to maintain the Terraform provider. So yeah, wrapping up, we have a tradition, as you may or may not be aware, that each guest leaves a question for the next guest without knowing who they are. So, what question would you like to ask? That could be about the project, not about the project, technical, non-technical, literally anything. It will be the first question that I'll ask next week.
Yeah, Steve, I'm gonna be honest. I had a really good idea for this one. I'm gonna give you the one that you should probably use, which
Okay,
is if you could do a collaboration with any other open source or any other CNCF project, what would you do and why?
I like
You
it.
could co-blogs, be like, hey, Cilium, well, we love you and we're a sandbox project. Like, let's do a thing. What would you pick?
I like it. That's a neat one. I'm intrigued to see what they say now.
Yeah, that should be fun. The
Yeah,
fun one, which I consider, was as soon as you're growing up in the cloud native world, when you become a graduating project and you're given the keynote at KubeCon 2028, what's your walkout song? But you can use that one as a backup if somebody doesn't come.
that's equally good. You may even get 2 for 1 next week.
Nice.
Yeah, they're good. So yeah, thanks very much, Brooks. It was a very insightful, you know, taking that four letter word and actually getting a better understanding of what it actually is, and the power that Wasm Cloud is providing and is going to provide in the future. So one of the things I wanted to make sure is that everybody knows how to get involved in the Wasm Cloud community. So do you want to kind of shout out a couple of meetings that you've got and other things that you've got going on in the next couple of months?
Yeah, I would love to. So I just want to mention you can find us on the CNCF Slack, or we have our own Slack at slack.wasmcloud.com if you're interested in joining and talking and asking questions. All of that is linked on our homepage, which is wasmcloud.com. The upcoming things that you should absolutely know about. First of all, every Wednesday we run our wasmCloud community meeting, which is open for anybody to join, give a demo, ask questions, even if it's just the WebAssembly ecosystem. We love having new people drop in, give an intro, and hang out there. Upcoming in 2 days, actually, is going to be an online, a virtual event that we're calling wasmCloud Innovation Day. That's going to be Wednesday, September 18th. That one is completely open for folks to join. It's going to be in East Coast US time. It's going to be from 10 a.m. to 6 p.m. So we're going to be rolling all day from essentially a virtual conference where we'll do a keynote, we'll do deep dives into different aspects of Wasm Cloud as a platform. We'll have some of our partners and people who are using Wasm Cloud in production come on and do demos. And then at the end of the day, we're all going to get into a virtual gather space, do some hacking on some good first issues, build some WebAssembly components, and there'll be an interactive workshop there, and all the maintainers are going to be hanging out, so you can ask them questions as well. So if you're interested in getting involved and you want the best bang for your buck, Cloud Innovation Day is going to be the thing.
Do you get a walkout song?
Sorry,
Do
what?
you get do you get your own walkout song at Wasm Innovation Day?
We have time. We have time to engineer that. And
There
I
it
did
is.
hear it.
I can make that happen.
Yeah.
Yeah, so thanks so much, Brooks. And again, stay connected to the Cloud Native Club on LinkedIn, Twitter, and YouTube. And until next time, stay cloud native. Thanks all.
Thanks.